Greetings, geometers. It's time for lesson 3-2 on the ruler and distance. All this is part of the third chapter on lines and angles. Write out postulate 3. The points on a line can be numbered so that positive number differences measure distances. So, for instance, if we have this number lines, rulers, whatever we have, if I want to know the distance between here and here, 7 and 2, it's just 7 minus 2, the distance is 5, the positive number difference. That measures the distance. And with a ruler, you know, you don't have to measure from the 0, you can measure from any place on the ruler and then just find the positive number difference between where you start and where you end, and there you have your distance. So this is the ruler postulate, postulate 3. Points on a line can be numbered as they are here so that positive number differences measure distances. Don't make that any harder than it is. It's pretty straightforward. It's just subtract the two numbers. And number 2, a point is between two other points on the same line if and only if its coordinate is between their coordinates. So for instance, if you look at what we've got up here, the number line I sketched out here is 4 between 2 and 7. Well, it is. It's between 2 and 7 because its coordinate, we call these numbers, we call coordinates. Its coordinate is between the two coordinates I said. So you could say that as 2 is less than 4, which is less than 7. So that's mathematically a way that you could express that. You could say, look at 4. 4 is between 2 and 7. So that's how we know that the point is between these two other points, 2 and 7. Don't outthink yourself on that one either. It's just the way it seems. Write out theorem 1, the betweenness of points theorem. Okay, so how do you say this? It might surprise you the way you say that. It says, if B is between A and C, then AB plus BC equals AC. Okay, so let's say we have this line, and we have point A on this line, we have point B on this line, and point C on this line. So is B between A and C? Yes, it is. And we could even put some coordinates on there if we wanted to show it mathematically, but we can see visually that B is between that. So what they're saying is AB plus BC equals AC. Right? And that's quite obviously true. So if B is between A and C, then AB plus BC equals AC. This is the betweenness of points theorem. So you see everything that we've got here in this one today, in number 1 here, writing out postulate 3, points on a line can be numbered so that positive number differences measure distances. And number 2, a point is between two other points on the same line if and only if its coordinate is between their coordinates. Demonstrated mathematically as 2 is less than 4 is less than 7. And write out theorem 1, betweenness of points theorem. If B is between A and C, then AB plus BC equals AC. Alright, so none of this is really rocket science. Sometimes it's so simple that it confuses people. So don't let yourselves get confused by that. It is just exactly as it says it is. Some of this you would call common sense probably. But we find a way in geometry to use this common sense in very efficient and specific ways, and you're going to be finding out how that's done throughout this chapter. Alright, I guess that'll do it from here. So, I wish you all a geometric night, and I will see you later.